Okay, so we are now in Unit 19, which deals with regression, Section 10.2. Basically, regression is we try to construct a line that's the best fitting line through our given data points. This line is called the line of regression. So first, we must have some type of linear relationship between the data points. And so we're looking at the number of stores of Starbucks that have opened from 1990 to 2014. And we can see it's somewhat linear, but we want to find the line that's closest to every single point that is plotted. That's going to be the line of regression. Now, to determine this line, we will use a formula to do this, or actually two formulas, because we have two coefficients that need to be computed. Now, once again, I'm just going to recommend to use your calculator to make these computations. So let's look at the formulas first of all. So the line has the following form: y prime is a plus bx. B is the slope. So y prime is your estimated value. X is your variable, and that variable is represented by the number of years since 1990. So B is the slope, how steep the line is. A is the intercept. The intercept is where the line crosses the y-axis. And so what we have to do is, since all of these values are based off of sums, we need to add a couple of other columns to our original data set. So our data set that is plotted here will be the following values. We have to compute x, y, meaning we multiply each x with each y. We have to compute x squared, meaning that we square each x, and y squared, we square each y. Find the sum of each column. N is just the number of pairs, in this case 14. So to calculate the slope, we use this formula: n times the sum of the xy column minus the sum of the x column times the sum of the y column divided by n times the sum of the x squared column minus the sum of the x column squared. So you take that information, you plug it in, calculate, we have 488.112. Now A, which is the intercept, we take the sum of the y column times the sum of the x squared column minus the sum of the x column times the sum of the xy column divided by n, 14, times the sum of the x squared minus the sum of the x quantity squared. We plug that information in, calculate, that's negative 1,105.657. So we now have a linear model. We should always round to around 3 decimal places. So what do we do with this linear model? Well, this linear model is used to make predictions. So let's say that we want to know how many Starbucks stores will be around, or estimated value, when x is 20. So you plug 20 into the formula and you calculate. You would say, and here we just round it, about 8,657 stores. It's not a perfect answer. It may not match the actual value in the real world, but it provides a target for someone to shoot for. Because remember, these are just estimated values. It's think of them as targets. And once in a while, they're fairly accurate, and they can guide data values. So now let's go ahead. So we look at a visual representation. We have the actual data values that are plotted. We have our line of regression. That's the line that best fits through all the data values. And we have the algebraic formula for this line. Now, it turns out that a key value that we need to be also list with the line of regression is called the coefficient of determination. It is R squared. And the way we read R squared, it just kind of provides a level of accuracy for a linear model. And we write it as a percentage. And all you're doing is you're taking the original R and squaring it and writing it as a percentage. The closer R squared is to 100%, the better predictions a linear model will make. So for this problem, R is 0.931, we square it 87%, which is a really good model. So we have a fairly good model for making predictions. It's not going to be 100% accurate, but sometimes having this tool is better than having nothing and just taking shots in the dark. But let's go on. So there's a couple of other examples for people to try to compute the line of regression. And we're going to work out one more example. So we'll work out this problem in which we are looking for, well, we already established a linear relationship between the work time, we'll say cardio per week, cardio hours per week, and the lifespan in years. So we've established that there's a linear relationship between these data values, so now we want to find the line of regression. So once again, as I mentioned before, I would recommend using your calculator. The calculator will compute the coefficients for you. And I do have a video that demonstrates that process. So our line of regression is y prime equal to the slope is 1.236. Our A coefficient is 58.423. We need to make a prediction when X is 12 hours of cardio per week. Insert that into the formula for X. So 12 times 1.236. And when we calculate this, we can estimate the lifespan of someone who works out 12 hours per week doing some type of cardio, and that would be 73. And so that is our section 10.2.